In part B, we have to prove the given identity. So we'll start proving the identity by first taking the LCM. The LCM will become cos minus sine and cos plus sine. So this will be cos plus sine and cos minus sine. This sine will multiply by cos minus sine, and 1 minus cos will multiply by cos plus sine. Opening up the brackets, we'll get sine cos minus sine squared, and then 1 multiplied by cos will be cos into 1 plus sine will be sine minus cos squared minus sine cos divided by the denominator. We can convert it using the identity a squared minus b squared equals to a minus b a plus b. So we can write it as cos squared minus sine squared. So sine cos minus sine cos will cancel out. So we'll get cos plus sine minus sine squared minus cos squared, and as in the denominator we needed a term in sine squared, so we'll replace cos squared with the identity cos squared is equals to 1 minus sine squared. Now as we needed 1 in the numerator, we can take the negative sign common and write sine squared plus cos squared upon 1 minus 2 sine squared, as sine squared plus cos squared is equals to 1, so we can write this as cos plus sine minus 1 upon 1 minus 2 sine squared, which was the identity that we had to prove. Now in part C, we have to use the results of A part 2 and B part to solve this given equation. Now this was the identity that we proved, which was cos plus sine minus 1 upon 1 minus 2 sine squared is equals to 2 into cos plus sine minus 1. Now from the previous part, we already know that cos plus sine minus 1 was equal. So we know that cos plus sine, and if you bring the 1 on this side, this will be equal to 0. So we can put a 0 over here as well, or we can simply cross multiply. So this will become cos plus sine minus 1 is equals to 2 cos plus 2 sine minus 1, and this is multiplying by 1 minus 2 sine squared. Opening up the bracket, we will get cos plus sine minus 1 is equals to, so 2 cos into 1 will become 2 cos, 2 sine into 1 will be 2 sine, minus 1 into 1, this will become a minus 1, and 2 cos plus 2 sine, so this would have been a minus 2, so this will become a minus 2, and then multiplying 2 cos by minus 2 sine square, this will become a minus 4 sine square cos. 2 sine times minus 2 sine square will become minus 4 sine cube, and 2 sine minus 2 into minus 2 sine square will become a plus 4 sine squared. Now to simplify this, we'll bring the cos plus sine plus 1 on the right hand side. So, and the negative terms of minus 4 sine squared cos minus 4 sine cube and 4 sine square on the left hand side. So we'll write it as 4 sine square cos plus 4 sine cube minus 4 sine squared is equals to 2 cos plus 2 sine minus 2, and this will become a minus. So this was a minus, so this will become a minus cos minus sine plus 1. Now taking 4 sine squared common over here, we'll get, so this will become a cos plus sine minus 1. So 2 cos minus cos will be a cos, 2 sine minus sine will be a plus sine, and minus 2 plus 1 will be a minus 1. So we can see that cos plus sine minus 1 will cancel with cos plus sine minus 1. So if we cancel this out, this will be 4 sine squared equals to 1. So sine squared will be equals to 1 upon 4, or sine theta will be equals to 1 upon 2. Now taking sine inverse of 1 upon 2, we'll get one of the answers. The basic angle is pi upon 6. So this will become pi upon 6, and we'll make a basic angle over here, which is also pi upon 6. So the two values of theta will be pi upon 6, and then this will be pi minus pi upon 6, which is 5 pi upon 6. Now, as we had to also use the answer from A part 2, we know that cos plus sine minus 1 was equals to 0. So, if in place of cos plus sine minus 1, we had replaced the 0 over here, we would have been left with cos plus sine minus 1 equals to 0. So, one of the other solutions would have been cos plus sine minus 1 equals to 0. As if we replace this with a 0, cross multiplying over here, it would have been a 0 altogether. So cos plus sine would have been equals to 1. And from the previous part, we know that the solution for cos plus sine is equals to 1 is 0.5 pi. So we'll add the two solutions as well, which are 0 and 1 upon 2 pi. So the theta will have four solutions: pi upon 6, 5 pi upon 6, 0, and 1 upon 2 pi.